All right, hey guys, welcome back. We are talking about bugs. So specifically talking about different types of bugs. So in software development, even a very seasoned software developer will still have, I think the number is 1 bug per 1,000 lines of code. So it's going to happen, right? That's just a part of it. There are two different basic types of bugs that we're going to look at. Two major types of bugs, right? Syntax bugs and logic bugs. So first we're going to look at syntax bugs. If our program has a syntax problem, what happens, right? That means something's typed wrong and it will not compile or interpret. So in this case, we've got a parse error, syntax error, so I gotta look around the camera, unexpected print in home, whatever, blah, 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 bug types on line 13. So PHP makes it easy for us, tells us what line it's on, so we can just skip to that line, and it's actually, the error is not going to be on the line that PHP, generally not. It'll not be on line 13 as it claimed, it will actually usually be above that. So and in our case, our program so far looks like j equals 5, n equals j plus 5, and we're missing the semicolon. So that's why our program bombed out. Let me put that in there, put the semicolon in, try run it again. God damn it, I have another one. Oh, now that I fixed the light, oh, it looks better. I know, right? Because when you're doing this stuff, you gotta have artificial light galore, but not. All right, what did it say? Unexpected sum, line 25. Yeah, so I think it's ironic that I'm filming, but I'm filming a segment on bugs, and we're having bugs. But we fixed the first bug, right? Let me see. A equals 5. So let's debug this, right? Since I can't figure out why it's dying. Oh, actually, it won't parse anything. Oh, okay. So I see where it is. Right here, it's actually way up above again. In this print statement, we have an open double quote, but not a closing double quote. So that's why it's bombing out. All right, so that's our first, n equals 10, right? So we fixed our first bug. Now let's create a comment to skip over this because we don't care about that now. Yeah, so the bug is usually not on the line PHP says it is. It's usually higher up. All right, so now a logic bug. Let's fix this to say sum again because that just makes more sense than total. Okay, so a equals 5, b equals 3, sum equals, whatever, and then print sum of a plus b equals sum. So if you probably see the bug already, but that's okay, we're going to keep going with it. So the interpreter will not complain because everything is syntactically correct. We don't have any errors in our syntax. We have an error in our logic. So let's run this guy. Sum of 5 plus 3 equals 2. That sounds wrong, and it is wrong because in our thing here, we've got a minus sign, not a plus sign. So that's our bug, right? It's a logic bug. So let's fix that. Yep, 5 plus 3 equals 8. So there's a difference. Yeah, so just trying to illustrate the difference between a syntax bug and a logic bug. Syntax bug causes the parser to barf because something is syntactically wrong, like a missing semiquote or a semicolon or a double or single quote that's not closed, or it can be a lot of different things. A logic bug is the program will run, it will be syntactically correct, the parser will run it, but something is wrong with the logic or the formula that we have or something. So let's comment out that guy and go to the next part. So just like there's a very famous example of a logic bug, one of the NASA, or was it not the NASA, the European Union, one of the Mars rovers, someone was using miles instead of kilometers, or not converting them, or kilometers instead of miles, and it basically caused the rover to crash into the surface of Mars rather than deploy nice and land softly. So it's a pretty famous bug, right? So in our conversion here, miles equals m equals 1, k equals m, and you probably see the bug already. The formula for converting miles to kilometers is kilometers equals miles times 1.6. You can probably see the bug, right? This will compile, or rather parse correctly, but it will give us the wrong answer because it's a logic bug. There are 2.6 kilometers in 1 mile, and that's wrong. Let me actually put a exit doohickey here so that we're not running the whole thing. Okay, 2.6 kilometers in 1 mile, that is wrong. There is 1.6 kilometers in 1 mile. So let's fix that. You know, we've seen this kind of thing already, this kind of bug. Another type of bug might be that someone might accidentally put the wrong variable in the wrong place or something, right? Instead of the wrong, operator, mathematical operator, like the wrong variable name or something, or just forget to do a conversion altogether. Whatever the problem might be, right? But so logic bugs versus syntax bugs. So how do we debug bugs if we can? Usually, if in the case of a syntax bug, the interpreter will create an error, it'll barf and not let the thing run. But if we have a logic error and we want to figure out where our logic is broken, when we've got a lot of code, that can be a tricky thing. It can be tricky to find where something's going wrong. So there's different ways to do it. I personally prefer using lots of print statements. That's the method that I know Linus Torvalds likes that, and then Dennis Ritchie, the author of the C program, one of the authors of the C programming language, likes that. There's Brian Kernighan and Dennis Ritchie. That's the way I like to do it. So you can probably, so for our fictitious program here, we're going to calculate the total square footage of 2 rooms. So the formula for that would be length, width, height, or length by width of the first room, or in this case height, width, multiply those together, and then take the second room and multiply those together, and then add those 2 together, right? And you can probably see the bug already just by looking at this, but I'm going to run it anyways. Let's do some math, right? Let's make these numbers real easy so that we're not doing difficult math. Okay, 50 square feet and 200 square feet. Well, yes, let's make it 100 square feet and 200 square feet is what this should look like. One is 10 by 10, the other is 10 by 20, so our total should be 300 square feet, right? A 10 by 10 foot room and a 10 by 20 foot room. That's 100 square feet and 200 square feet, and we add those together, that's what it should be. And we're only getting 130 square feet, so that means something somewhere is wrong. So let's take a look. If I was going to do print statements, print room 1 square feet, room 1 square feet, room 1 square feet is 100 square feet, it's 10 by 10, that's what we're expecting. And we could even do print height 1, and let me fix the spelling so we don't create another bug while debugging. Just depending on how far we need to go, we probably wouldn't need to go all this far, but we can see height 1, width 1 is 100, 100, room 1 square feet, and we're still getting the wrong answer. So the next thing I would check, oops, I'm going to add in a space here to make this more readable. room 2 square feet. Room 2 square feet is coming up at 30. So we've got height 10, width 20. 10 times 20 should be 200, but it's not. So if we look above our debug print statement, we can see there's a plus sign instead of a multiplication sign. So let's fix that. And now we get our total square feet of 300. We get 100 plus 200 equals 300. So that'll make, and with these artificial examples, it may not make a lot of sense, but once we start, digging in and making bigger, more complicated programs, that's a way cool, or that's, it'll make more sense. We'll have more opportunities to debug things. So, all right, so there's no exercises for this one. All right, that's it. Awesome. I'll see you guys on the next one.